count day is complete.
Yeah, you can go back.
We
All right,
have
good.
completed our count day. Thank you.
Okay, so as I get ready to do these problems, okay, I look at this problem. What's the deal? What caused me to say this problem's more fun than it should be? Mr. Pluckin, what do you got for me?
It says limit does not exist.
The limit is, why do you say the limit does not exist?
When I plugged it in, it's an error.
Error. So you got error, so you said, okay, limit does not exist. You're using the fact that the bottom became 0. Right? Put a 3 in the bottom, 3 minus 3 is 0. 0 at the bottom means it does not, the value does not exist. So you went ahead and said the limit does not exist. Seems like a reasonable approach. Yes, ma'am.
Is 0 over 0 1?
Is 0 over 0 1? Interesting question. What's the top of this function, by the way? 0. So I got 0 over 0. And by the way, 0 over 0 is going to have a special place for us. Why? Well, here's how we're going to figure this out. You're going to write this function into your calculator, and you're going to test points to get closer and closer. When at the end of that, hopefully you'll figure out what's going on here.
Is there a way to
Then we got a 0, and then got a 1. What is the limit of this function? 6. Why? Why would the limit of, as, let me write it down for a second, because someone gave me a cuz. I'll give him a second. Give me the cuz. Somebody over here was hand up. Somebody said cuz. Yes, ma'am. So approaching left and right. So it is in fact 6, or at least feels like it has to be 6. What is this function on the left as you guys are chattering? What is this function? What's weird about this function? That man's got his hand up and give him credit for it. Go. There's a hole! There's a hole in this function. You're not eating this class. Yeah. Now, how do you know there's a hole, Mr. Bodell?
Because the bottom is x minus 3, so there's a hole at 3 because, or at.
That would make an asymptote typically.
Oh.
Why is it a hole, not an asymptote? Yes, sir.
Because when you like factor out x squared minus 9 makes an x minus 3 on top as well, which is, I think.
So in the land of algebra 2, you were taught to do this.
Oh, it's 6. I see it.
And you were taught you could do this, but one side issue I want to remind you of, and that is, this is only true if what?
There's only one thing on the top.
No.
What is only true if?
This function here is equal to this function here at every place except x equals 3. X cannot be 3. Because at 3 there is a undefined spot or a hole. But when I'm taking a limit, does it matter what's at the spot? No, it's just what you're approaching. This function looks just like a line, x plus 3, except at the point we're testing, so we don't care. Yes, sir.
So why is a hole different than an asymptote? Why would we put the limit?
Because an asymptote, what are we doing? We're approaching like this, right?
Yeah.
This function, no, can't draw it. There it is. This function looks like this. 1, 2, 3. Looks like this until you get to 3. Is that right? Yeah. Yep, x plus 3. So it looks like this until you get x equals 3, and then you suddenly have a hole there. Now the good news is as I approach from the left and the right, I'm approaching the hole. I'm not going to infinity. I'm approaching that spot. And the closer I get to 6, I actually can't reach it because at 3 it's undefined. We don't care about that when we take the limit. It's what we're approaching, not what we have. Yes, ma'am. Yes, ma'am. So whenever you have 0 over 0, you're going to start the process of dealing with it by checking for holes. How do you check for holes? Back to top and bottom, cancel out the common factor. The moment you cancel the common factor, plug in the value, you're done. Do not simplify, not spend hours doing, just cancel out the common factor, and then you move forward. Stanbridge?
Wait, what do you mean by plugging the common factor?
I did. I said cancel out the common factor.
Plug in the 3.
And then so
So once you realize you've got x minus 3 over x minus 3, you go ahead and cancel that out.
okay.
Now, in theory, we're supposed to be, oh no, we can't do this, x equals 3. But we know if we're taking a limit at 3, we don't care what it is at 3. That's the least of our, we don't care what's there. It could be anything. Don't even look at it. Don't care.
Okay.
What I care is when I'm approaching left and right. So as I approach left and right, I cancel that out, I can actually get it just simply by plugging in afterwards, right? If I plug in a 3 now, it was approaching 6.
So you plug in a. Oh, you plug in a.
Plug in the value you're testing, right? The moment you cancel it out, you plug the 3 in there.
Oh, so then it's 3 plus 3.
2 plus 3 is 6. Make sense?
Yeah.
Good? All right, everybody try 45, 46, 47, 56. On 50, oh wait, 47, we might need help from somebody actually attended algebra 2. On 56, it says simplify. That's a lie. What it really meant to say, that's the book hit, and I wrote it down. It's like, that's not what it is. It's make it worse. I'll show you what I mean a little bit.
Should I write that?
Yeah, if you want to just write, yes, if I make it worse, that'd be good.
Alright.
But 47 is something you're going to struggle with because you don't know how to do algebra 2.
For like the final answer for that function.
Or what? Do you know how to factor? X cubed minus 8 is the question. What are those factor terms? No, that's not it. That gives you weird terms. There's a whole factor peg. Different perfect trinomials. Perfect trinomials. Nobody ever remembers what it is. Which gives me a chance to talk about a different topic one time.
Same opposite velocity.
That's, now you're sounding it.
It's so, but
I don't know what that is.
it's
Yes, I'm with you.
same, opposite, different. The same, opposite, always positive.
Okay, I'm going to believe you. But I don't know what that means. But we're going to do it the hard way. Because we don't memorize these things.
So it's just like the mindset. So how does that? Just interject.
Did I give you math wrong? No? So I had to factor that. You had to factor the top and bottom. Did I factor?
Yeah.
Okay. Then I cancel out the common factor. That would be 2x minus 3. So then I plugged in the -1 to see what I get. The moment you cancel out the common factor, you get rid of the whole, essentially. Then you just throw it in and you're done.
Yeah.
It's 56 weird because you have
This is weird because the square root bar makes it almost impossible to factor. You guys remember the factor pattern? You're the boss. Oh, that's not the factor pattern. You guys. You guys.
It's the same, it's like the same.
She's saying soap. I don't know what soap means. Minus x. Nope, can't do it. Can't. Oh, that's good. X minus 2. And then I would get x squared plus 2x plus 4. Theoretically, something you learned in algebra 2. Over x minus 2. Okay.
No, I think I actually figured it out.
Okay.
I'm sorry.
But if I got an x minus 2, that's a factor, right? When I get done.
I see. Yes.
Or you can look at this. You just divide x minus 2 out of this, and that's your answer. I don't care which way you go. I live with both of them. 2, 4, 8, 12. I'm wrong. Darn it. No, I got 12. What? What are the people getting? Okay.
I originally got 0.
All right, so 56 is just a trick. So let me just let you know the secret. Let me give you a secret straight away. Limit as x approaches 3 minus 2 over x minus 3. How do I simplify this? Supposedly, and again, I stole this hint from the book. It says simplify. We're not going to simplify this. The problem, yes, ma'am. Okay, so what we're going to do is we're going to plug in, say, a 3, get 2 minus 2, that's 0 over 0, frowny face, need to factor it. How do you factor something with a square root bar in it? Yes, ma'am. We're going to have to, I'm not going to square it, I'm going to write its complex conjugate, is what we used to call that in the good old days. And about 4 years ago, somebody said complex conjugate. Like, wow, somebody knew what to talk about. Basically, we're going to write the same thing, but instead of a minus, I'm going to write a plus. Yeah? So limit as x approaches 3 of times all over. Now, there is a significant thing that makes your life better here. Do not simplify the bottom. Leave it alone. Do not simplify the bottom. Simplify the bottom, you're on your own. You're going to spend hours doing this problem. You're on your own. So whatever you do to the top, I'm to the bottom, right? I multiply this complex conjugate to turn it into a non-square root bar. That's all I'm trying to do so I can factor it. Okay? Complex conjugate is what turns it into a non-square root situation. So if you do this, you get x plus 1 minus 2 square root x plus 1 plus 2 square root x plus 1. That goes away. It leaves me a whopping minus 4 all over x minus 3. And then this lovely expression still hanging on there.
Wait, can you do the top one better?
Square root x plus 1 times square root x plus 1 is?
X plus 1.
X plus 1. Well done. Negative 2 square root x plus 1 plus 2 square root x plus 1 is?
Oh, 0.
0. Negative 2 times 2 is?
No.
Negative 4.
Okay.
And by the way, we usually when we do a complex conjugate, so that middle term always cancels us. We don't have a square root bar. That's what we're trying to get rid of.
Can you just make it x plus 5?
I would say x minus 3 was what I would do.
That's what
And that's really important because you got x plus 5, you got problems you're going to not be able to get out of. So limit as x approaches 3 of x minus 3 over x minus 3 times square root of x plus 1 plus 2. Hey, find the common factor. X minus 3, which leaves a 1 on top. Right, everybody? It does leave a 1 on top. When I divide top and bottom of x minus 3, I get a 1 on top. And then the moment, this is why I say the moment you do it, you immediately plug in the value. Don't keep working with this problem. You're done, right? You've got a common factor, cancel it out. It should work. Plug in a 3, I get 1 over the square root of 3 plus 1 plus, oops, sorry, plus 2. I did that badly. Goes. And that gives me 1/4, I believe. Yeah. Oh, if you have a calculator desk, you can do the whole, let's see if I can pick numbers closer and see if I can pull it off. Don't do that because I'm going to choose something like 7/13, and good luck finding it.